Okay guys, here in this section 6-4 we're talking about reference angles. And so the first thing that we come to is that the values of the trigonometric functions of angles that are greater than 90 or less than 0 can be determined from their values at a corresponding acute angle called a reference angle. So here we have a reference angle defined. It says let theta be an angle in standard position. Its reference angle is the acute angle, theta prime, formed by the terminal side of the angle and the horizontal axis. All right, the terminal side and the horizontal axis. Now here's the key. It's an acute angle, all right, and of course by definition acute means between 0 and 90, so it's got to be positive. All right, so the reference angle is always positive. So let's look on a graph now so that we can get an idea of what we're talking about when we say we're looking for a reference angle. So like if this is the angle that you're looking at from here to here, the reference angle, theta prime, would be the angle from here to here, right? And so the reference angle in degrees here would be 180 minus the angle itself. So if the angle is in this position, you'll go 180 minus the angle itself, or pi if you're using radians minus the angle itself in radians, and the result, whatever's left, would be the reference angle from here to here. Okay, so likewise here, if this is my angle, right, and I'm looking for the reference angle would be here, because remember it's the acute angle from the terminal side to the horizontal axis, right? So this is what we would need. So here you would take the entire angle and subtract off pi in radians, or subtract off the 180 in degrees to come up with your reference angle. And so here, if your reference angle is all the way around to here, 300 and something looks like, then if I wanted the reference angle, which is from here to here, then I would have to go all the way around 2 pi minus whatever the angle is, and that would leave me with the reference angle. Or in degrees, it's 360 minus the angle. So based on wherever the position is, and they've given you quadrant 2, quadrant 3, and quadrant 4, because if it's in quadrant 1, then the reference angle matches the angle itself. All right. So the only time you have to calculate something different is if it's in 2, 3, or 4. And these give you the outlines onto how to find the reference angle based on which quadrant that it's in. All right. And so just to kind of provide some more usefulness, it says by using the reference angles, you can extend the scope of the trigonometric values. Like for example, if you know the values of the trigonometric functions at 30 degrees, then that means you know the function values for all angles, which 30 is a reference angle, right? And so here's kind of a table that shows you kind of the values of the sine, cosine, and tangent based on various degrees. The most common ones are used, the ones that are on the unit circle from 0 to 90 are all in here, 30, 45, 60. And it would be helpful to commit this to memory if you could. So again, you've got the degree measure, then you've got the radian measure. So at 0 degrees, sine is 0, cosine is 1, and tangent is 0. All right, and if you were to draw it out, you would be able to see why that's the case. So then at 30 degrees, you've got the values. 45 degrees, you've got the values. 60 degrees, the values are here. And then at 90 degrees, sine is 1, cosine is 0, and then tangent is actually undefined at 90 degrees. Okay, so these main ones, 0 and 1, we should memorize for sure. Probably the 1/2 would be easy to memorize as well. And then we need to know tangent of 45 degrees is 1, and so on. And then they also have 180 here, which is also good to know. And then they've got 270 listed there as well. So that's kind of a chart for the of the common values, or the values for sine, cosine, and tangent for the common angles that are used. All right. Now, let's go through here and see if we can find the reference angle, theta prime, for this angle that's given. All right, so the first two are given to us in degrees. So if my angle is 150 degrees, then I want to find the reference angle for that. Okay, so one thing that's helpful is to draw out a quick sketch. And so a rough sketch of 150 degrees, it'd be right here roughly, all right, 150. Okay. So let's identify the reference angle first. So my reference angle would be here, right? So that's what I'm looking for. And how am I going to find it? Well, if you're in quadrant 2, how do you find it? You need to do, we're in degrees, so I need 180 minus the angle. And most of you could figure that out. If I want this piece, I need to do the whole thing 180 minus the 150. So 180 minus the 150, that's going to make my theta prime equal 30 degrees. So the reference, even though the angle is 150, the reference angle here is 30 degrees. All right, so likewise on the next one, if we sketch out a 315 here, that would be roughly here. All right, so there's my 315. All right, 315 degrees. The question is now, what's this reference angle right here? And again, if we're in the third quadrant with degrees, we want 360 minus the angle. So we'll go 360 minus 315. And then that's going to make your reference angle equal to 45 degrees. All right. A couple of more now in radian measure. So 3 pi over 4. Let's see if we can figure out where that is on the radian measure. It's helpful when you've got radians like that to look at the unit circle because it'll tell you what the angle should look like at least. So I know 3 pi over 4 radians looks like this. 3 pi over 4. And so now we're looking for this reference angle. Sketching it out helps you kind of see where the reference angle is. So I need to do 180 minus the reference angle, but we're in radians this time, so we want to do pi minus the reference angle. So this is going to become pi minus the reference angle, which is 3 pi over 4. And so we need a common denominator here, which is 4 pi over 4 minus 3 pi over 4. And so what does that give me for my reference angle? It gives me pi over 4. So my reference angle here is going to be pi over 4. All right. One more to look at here. Sketch our graph again. And we got negative 5 pi over 6 this time. So this is the first negative one that we've looked at. Negative 5 pi over 6. So let's go to our reference, to our unit circle here. Here's 5 pi over 6, but remember that's positive 5 pi over 6. So negative 5 pi over 6 would come over this way, all right, down to here. And so when I draw this, then I know that here's where what my drawing would look like. That's negative 5 pi over 6. So here's the reference angle that I want. All right, now, probably the best way of doing this, okay, let's think about it for a minute. So we're in this quadrant, right? And so if we're in this quadrant, then we want the angle minus pi. But if we take that negative angle and then subtract another pi off of it, we'll just end up with a further negative angle, right? And so what we need to do is we need to take that and correspond it to the, and remember, reference angle always has a positive value anyway, so we're going to have to be careful with that. And so what we'll need to do here is we'll need to change, by the way, the original was negative 5 pi over 6. What we need to do is we'll need to change that to the corresponding positive angle value and then subtract it from pi. All right, and so yeah, if I look back here and I see that 5 pi over 6 is here, and we know that this is where we're at going back this way, well, what's the positive value? The unit circle gives it to me immediately, 7 pi over 6. So what I'm going to do is I'm going to change this to 7 pi over 6, and then follow my pattern like I'm supposed to by subtracting pi off of it. So if I subtract pi out of that, I am now left with my reference angle. So we'll subtract pi. We have the same problem of coming to the common denominator that we want here, and I would say that it is 6. So I want 7 pi over 6 minus 6 pi over 6. And so that's going to make my reference angle right here equal to pi over 6. which will be our correct answer. So if you've got a negative angle to start with, you can write in the corresponding positive value for that same terminal side that you're looking for, and then take that and plug it back into your pattern as far as what to subtract, and then come up with the right answer there. Okay?